Some flights seem doomed from the start because of a massive storm, a major breakdown, or an emergency you just can't hide. But then, there are those other, way creepier cases where everything looks pretty normal. The plane takes off, the crew does their thing, communications keep going, no yelling, no chaos right away, no obvious sign that something's going wrong, and yet, little by little, almost without anyone really noticing, things start to go south. The story of Flying Tiger Line, Flight 66, falls into that kind of category. Accidents that are hard to hear about because they don't come from one big mistake, but from a growing feeling of something going wrong, getting tenser and tenser inside a cockpit that's supposed to have everything under control. It's February 19th, 1989, at Changi Airport in Singapore. It's 5:30 in the morning, and Flight 66 from Flying Tiger Line is just waiting to taxi to the runway. Flight 66 is part of an international cargo route operated by Flying Tiger Line. That night, it starts at Singapore Changi Airport, taking off for Sultan Abdul Aziz Shah Airport in Kuala Lumpur to make a stopover before heading on to Kai Tak in Hong Kong. The first leg between Singapore and Kuala Lumpur is short, just about a 30-minute flight. That's actually why it might feel deceptively simple. It's not a long journey. It's not about a transoceanic journey or a complex operation at first glance, but rather a relatively short hop that, on paper, shouldn't pose much trouble for an experienced crew flying a Boeing 747 freighter. However, the arrival airport has a key detail that early morning. Runway 33 is in use, but its ILS isn't available. So they have to land using an NDB approach, a less precise and more demanding procedure that requires more attention from the crew. The plane involved is a Boeing 747-249 FSCD, registration N807FT, a big wide-body freighter built to haul cargo on long-haul international routes. It's one of those 747 versions that really show the power of late 20th century air freight. A massive, sturdy machine, designed to carry huge loads across continents and built to run non-stop for years on tough global routes. This particular plane made its first flight on November 1st, 1979, and was delivered new to Flying Tiger Line in December of that same year. By now, the aircraft was owned by FedEx. Its manufacturer serial number was 21828, and its build number was 408. It had logged about 34,030 flight hours and over 9,000 cycles, which is totally normal for a cargo 747 from that era. Flying Tiger Line was a well-known American cargo airline, known for decades for its role in international freight transport. It had built a strong reputation in the cargo sector and operated long, complex routes with large capacity planes, including the Boeing 747. In the cockpit, there are 3 crew members. At the controls of the 747 is Captain Frank Halpin, 59 years old. With him is First Officer John Robinson, 54. Completing the crew is Flight Engineer Ronald Benton, 70. Also on board Flight 66 is the Leonard Solevsky, a 53-year-old mechanic. At 6:03 in the morning, Flying Tiger's 747 starts its takeoff roll down the runway. They lifted off without any issues and began the short trip to their destination. The plane was flying under IFR rules on airway Alpha 464, initially climbing with the first officer at the controls. In those first few minutes, a small issue pops up that doesn't seem serious on its own. the crew mixes up the departure frequency and replies on a different one than expected. That Singapore had assigned to them. After several attempts, they finally make proper contact with the radar and continue climbing up to flight level 2. The cargo plane moves along without any obvious issues on that short night hop between Singapore and Malaysia. The cockpit of a 747 freighter at that hour feels mechanical and routine. Engines steady, instruments glowing in the dark, tired voices used to going over procedures again and again. The plane heads toward its bang while there's mist in the area and fog with changing visibility during that early morning. ARTIS reports, among other things, visibility at 6,000 meters, runway 33 in use, and that the runway's ILS isn't available. As the 747 approaches Kuala Lumpur, things in the cockpit get a bit murkier than they should. The crew gets clearance to KL, but the identifier isn't as clear or straightforward as it should be. In the area, there are several points and aids with similar names, and the control itself. The local controller calls the airport KL. What should be a clear reference starts turning into a confusing talk about radios, frequencies, and exactly which approach they're going to do. The flight is assigned an NDB approach to runway 33. But even in the last few minutes, there are still mentions of the ILS, even though that procedure for runway 33 is listed as unavailable. The crew isn't fully on the same page, and you can tell by how they talk, showing their uncertainty in the back and forth corrections and the first officer's increasingly irritated tone. At 6:27, Kuala Lumpur asks the flight how far they are from the VBA navigation radio. When the crew says they're 50 nautical miles out, the controller clears them to descend to 5,500 feet. Shortly after, at 6:28, the first officer lets slip a comment that perfectly captures the mood at that moment. He says they still only have flags on the ILS, a way of saying that the instrument landing system isn't giving them anything useful. It works, but the cockpit doesn't sound like a crew that's building a clear, shared picture of what's going on. It sounds more like a crew trying to piece together something on the fly that should have been clear from the start. The airport is already pretty close. At 6:31, when the captain asks about the ILS status, the tower replies that the ILS for runway 33 is available, but the ILS for runway 15 is indeed working. This is a key moment. Here, there's an alternative. They still have room to break the sequence, rearrange the cockpit, and pick the procedure that's easiest or clearest for the crew. However, the captain rules out doing an ILS approach to runway 15 and decides to continue with the arrival to runway 33. Right after, he tells the first officer to just reach the KL and then turn heading 330. The first officer responds frustrated. "How the hell do you expect us to find the runway?" That line isn't just a complaint. It's a emotional and operational warning. It's the sign of a pilot who's not feeling comfortable with the situation in front of them. But that discomfort isn't enough to break off the approach. Then comes the crucial moment. At 6:32, the controller gives the instruction that will decide the flight's fate. Tiger 066, descend to 2,400 feet. Cleared for NDB approach to runway 33. The intention was to authorize the descent to 2,400 feet, the published altitude to start that approach. But the mode, he wasn't very clear about it. Instead of giving a straightforward order like Descend and maintain 2,400. The instruction was given in a shortened way. In the cockpit, the captain took it as permission to drop to 400 feet and replied, "Okay, 400. But the right altitude for that segment was 2,400 feet, not 400. Still, the crew acted like the clearance really was to go almost down to the ground. Nobody corrected the captain, and they started descending. From there, everything happened very quickly. Quickly, the captain tells the first officer to keep going, that he'll guide him through the approach. He talks about frequencies, mentioning 255 and 355, which correspond to Kilo Lima and Marker Sierra Mike, the NDB references, and the localizer for the final approach to runway 33. But almost immediately, the first officer notices that something isn't quite tuned right. A brief but telling argument breaks out. One says it's correct. The other insists it's not. They double-check the numbers and then check again. The captain ends up admitting his mistake in the choice. It's not an open fight, but it is a back and forth that eats up attention just when the approach calls for the opposite. Order, clear priorities, and keeping an eye on the vertical profile. In the middle of the confusion, the first officer drops another stinging comment. How about this? Let's just go around and do an ILS approach. It's probably the most important objection voiced in the cockpit during those final minutes. And right after, he adds an even more worrying one. I don't even have the approach chart in front of me. At that critical moment, he doesn't have the mental map or the physical reference that should guide him on routes, minimum altitudes, and restrictions. But the captain, instead of stopping the maneuver, just reassures him. Relax, it's okay. Keep descending to 400 feet. It's a chilling line, precisely because it sounds calm. There's no panic, just an experienced commander confirming an altitude that's leading the plane straight into disaster. The descent continues. The captain says that if they feel uncomfortable and can't get out of the clouds, they'll go around. The first officer just replies, "Okay, the plane is still descending." They keep going through the checklists. At 6:33, you can hear the flaps being moved, but outside the cockpit, the reality is different. The 747 is descending in the dark towards some high ground southeast of their bang. The terrain is coming up fast from below, while the crew is still trying to sort out radios, references, and settings. Then the plane itself tries to save them. The GPWS goes off. It's a loud, clear warning, made to wipe out any doubt. It doesn't ask you to interpret or suggest. It commands, but there's no strong reaction to change the flight path right away. Instead of a quick, evasive move, the conversation stays scattered. The captain asks if the first officer has the ILS tuned in. The first officer says yes. Meanwhile, the GPWS voice keeps repeating over and over. The engineer starts a sentence he never finishes. We're 100 feet away when another voice hears it and says, "Shit." That's the split second when everyone finally gets what's happening. But it's already too late. No room for error. At 6:34, the huge 747 crashes into the southeastern slope of Bukit Hitam Puchong, about 9.8 nautical miles southeast of Subang, at roughly 437 feet above sea level. The impact destroys the plane. All 4 people on board die. After the crash, the fire breaks out. For 2 days. The hardest part about this final stretch is that it doesn't look like the plane was out of control. There was no structural failure, no explosion mid-flight, no massive storm tearing the aircraft apart. What there was a fully controllable plane, flown by pros with thousands of hours of experience, descending in an orderly way to the wrong altitude during a poorly understood approach. So, what happened? Was the crew the only ones to blame for this disaster? The investigation made it clear pretty early on that there wasn't a major mechanical failure on the plane that could explain the accident by itself. The Boeing 747 was flyable, meaning the main problem wasn't a critical mechanical issue, but rather how the approach was managed and how the instructions were understood. One of the first things looked at was the actual clearance from air traffic control. The tower gave the descent order, using a phrase that was a bit unclear. Descent 2,400, meaning 2,400 feet. The problem was that saying it that way made the captain hear it as forero, meaning 400 feet. And the worst part wasn't just the initial confusion, but that the misunderstanding wasn't corrected. The captain replied, "Okay, Fordero," showing he'd understood a completely different altitude. Yet the sequence kept going. The investigation found that phrasing was a major contributing factor, but it also made clear the accident couldn't be blamed solely on the controller. The report and later analysis make it clear that the crew didn't properly follow the published instrument procedure. The NDB approach to runway 33 was supposed to start at 2,400 feet, and there were also much higher minimum sector altitudes in certain areas. However, the plane descended well below what was safe for that segment. In other words, even though the ATC communication added to the confusion, the cockpit should have. They noticed that the descent didn't match the approach chart. And here's one of the biggest findings from the investigation. The first officer admitted in the cockpit that he didn't even have the approach chart in front of him. That's a huge deal, because in a non-precision approach, like an NDB, the chart isn't just a minor detail. It's the guide for courses, minimum altitudes, and the descent profile. The investigation took this as a very serious sign of poor immediate preparation for the approach. They also looked into how the cockpit was managed. The CVR shows the first officer clearly voiced concerns. He wasn't comfortable with the NDB approach, preferred the ILS to runway 15, and also voiced his frustration about not having the chart in front of him. However, those concerns never turned into firm action. There was no clear call to abort the maneuver, no decision to go around earlier, and no strong stance on descending to 400 feet. The captain, for his part, downplayed those concerns. He raised objections and acted with overconfidence, like he could figure out the approach on the fly. The investigation saw this as a textbook case of poor CRM, with the first officer lacking assertiveness and the captain's authority not being balanced by the rest of the crew. Another thing that stood out was the confusion over the KL references. During the approach, the crew didn't have a clear picture of the exact point the clearances were referring to. There was several references were identified similarly, which caused confusion about frequencies, rounds, and the actual procedures to follow. Even in the final minutes, there were still mixed comments about an ILS for runway 33 that hadn't been available from the start. The investigation concluded that this loss of mental clarity during the approach was a clear sign of degraded situational awareness. The GPWS was another key point. The alarm sounded loud and clear, repeatedly ordering, "pull up." But the crew didn't respond. It reacted with an immediate aggressive escape maneuver. The investigation focused a lot on this because it shows that even when the plane was still trying to warn of the danger, the cockpit was stuck in its own confusion. That lack of an effective response to such a clear alarm backed up the conclusion that the crew had completely lost sense of their actual vertical position relative to the ground. As for external factors, the weather played a minor role, but not non-existent. There was fog and mist in the area, with varying visibility during the early morning hours. It wasn't a severe storm or an extreme weather event, but the conditions were enough to make a poorly managed approach even more dangerous. The bottom line was pretty straightforward. Flight 66 was a controlled flight into terrain. The plane was under control, but the crew descended below a safe altitude during an NDB approach after misinterpreting a authorization and without properly following the published procedure. On top of that, there was poor cockpit coordination, inappropriate controller phraseology, inadequate approach preparation, and low situational awareness in the final minutes. The accident also had major consequences for air safety. It led to a stronger emphasis on the importance of using standard phraseology, crew resource management, CRM, and immediately responding to GPWS alerts. In fact, this case became a reference point for classic example of what shouldn't happen in an instrument approach. Yeah, I'm going to put you on 147, and that'll give you an experienced crew, a plane with no major issues, and yet a chain of human errors and miscommunication that ends in disaster. Flying Tiger Line, Flight 66 shows that in aviation, it doesn't take a huge explosion or an impossible failure for a tragedy to happen. Sometimes, all it takes is a misunderstood approach, a wrong altitude,